Vinod sir, for engaging this session and giving me this opportunity to interact with you. So today we are going to cover differential equation portion, which is a very plus point for those who attempted, as this is totally a numerical based part. If you get the right answer, then it will definitely right. So let's start our today's session. One by one, we cover the OD as well as PD, previous year questions. And don't worry if you didn't aware about these differential equations portion. But by the end of this class, you will definitely going to score 30 marks in upcoming CSR NET exam. So starting with a very first question. The question is on ordinary differential equation and a very rare problem. Yx is the solution of the equation 4xy double dash plus 2y dash plus y is equal to 0, satisfying y is 0 is equal to 1. Then y double dash 0 is equal to. So here in this question, we have given a equation with a condition also, and we are to find y double dash 0. So here we can see this equation is not a constant coefficient equation, as we have done already 3 lectures by this platform related to ordinary differential equation. And during these lectures, we haven't covered these type of problem. So this is a very different problem. Here we can see y double dash with x. So not a constant coefficient equation, and also not a homogeneous type of equation. If here we have x square and here we have x into y dash, then we can solve it by using our method. Now what we can do here, see, you don't need to solve whole question here. Just substituting this condition. In differential equation, if we go for the manual method, then it will be a very lengthy process. So today we are going to learn some new short tricks. So just substituting this back in this equation, we have 4xy double dash plus 2y dash plus y is equal to 0. When we substitute y 0 is equal to 1, this means x is equal to 0, then y is equal to 1. So here x is equal to 0, give 0 plus 2 y dash x is equal to here x, and this is also function of x. So x is equal to 0 plus y 0 is equal to 0. Here we have y 0 is equal to what? 1 is equal to 0. So we get y dash 0 is equal to minus 1, and this will divide minus 1 by 2. But the question want y double dash 0. So now what we can do, we can, given differential equation, we have this equation, we can differentiate this differential equation. When we differentiate this, we get here y double dash, here y dash. By this, maybe we get our answer. So let's try differentiate this equation. So here, this is also function of x, this is also function of x. So by using UV rule, 4xy triple derivative plus 4, the derivative of x is 1, so y double dash, plus 2, the derivative of y dash is y double dash, plus y dash x is equal to 0. Now substituting 0 as we want the value at 0. So when we substituting x is equal to 0, here this becomes 0, this will become y double dash 0, and this will also y double dash 0, y dash 0 is equal to 0. Now from here y dash 0 is equal to minus 1 by 2, and this will become 6y double dash 0 is equal to 0. So finally we get y double dash 0, which is equal to 1 upon 12. By taking this 6 right hand side, we get 1 upon 12, which is also given in the option number 2. So this is our right answer, 1 upon 12. So there are many ways to solve a single question. So basically in differential equations, if we have the condition, by using this, we can solve our question. So just we have substitute this and we get the final answer. Let's try another problem. Yes, this question is based on Cauchy problem. Let uxy solve the Cauchy problem. Curl u upon curl y minus x curl u upon curl x plus u minus 1 is equal to 0, where minus infinity to x infinity, x lies between minus infinity to infinity, and y greater equal to 0. And also we have given one more condition, ux0 is equal to sin x. And we are to find the value of u0, 1. The options are 1 minus 1 upon e, 1 plus 1 upon e, 1 minus 1 minus sin e upon e, 1 plus 1 minus sin e upon e. Obviously, there will be one out of these four. All are different here. So there are so many questions in previous year problem based on this Cauchy problem. So in these type of problem, we first write Lagrange equation, then we solve further. So first of all, in Cauchy problem, we have generally a equation of the form curl u upon curl x with a, suppose, plus b curl u upon curl y, and is equal to some another function of u. So in these type of problem, we can write Lagrange equation as dx upon a, dy upon b is equal to du upon fu. And then solve these differential equations to get the final solution. So here also, we have the equation, given equation as curl u upon curl y minus x curl u upon curl x plus u minus 1 is equal to 0. Write this equation in this type of form, the standard form. So taking curl u upon curl x first, then curl u upon curl y, and take this to the right hand side, 1 minus u. Now we can write Lagrange equation. We get dx upon this minus x, dy upon the coefficient of this, that is 1, and du upon 1 minus u. Now, no need to solve further. First see what question wants. Here, we have given the condition ux0 is equal to sin x. It means we have to substitute y is equal to 0 and the value of u will become sin x. The x is not changing. X is fixed. But who is changing? Y. So focused on y and u. U is also changing, sin x. So take comparison between y and u only. Maybe we get our final answer. So take y and u equation. These two equation only. From these two equation, we have dy by 1 is equal to du upon 1 minus u. So solving this, here the variable are already separating. So direct integrating. Here we get y. Here we get log 1 minus u with negative sign, as the derivative of minus u is also again minus integration, plus log c1 taking as a constant. So here we get further from the negative sign, the log takes its upward with inverse sign, and log a plus log b is log a into b, and here y. So we get 1 minus u inverse c1 is equal to this log become e raised to power y. By this, we get 1 upon 1 minus u into c1 is equal to e raised to power y. Now, using this, what we can do, we have the condition. Which condition? ux0 is equal to sin x. So substituting this condition, ux0 is equal to sin x. U is equal to sin x, 1 minus sin x, c1, and y is equal to 0. e raised to power 0. So we get C1 is equal to 1 minus sine x. So substituting this constant here, we get the final solution. What is the solution? 1 upon 1 minus u into 1 minus sine x, as C1 value is 1 minus sine x, is equal to e raised to power y. So we get here just reciprocal because we want u. So 1 minus u is equal to 1 upon e raised to power y. Here we have to find the value of u01. u01. So u01. That means substituting x is equal to 0 and y is equal to 1. Substituting x is equal to 0, sine 0 is 0, and y is equal to 1, e raised to power 1. So from here we get 1 minus u is equal to 1 upon e, and u is equal to, at 0, 1, we have already substituted 0, 1 here. u01, taking this side and this side, 1 minus 1 upon e. So that is our final answer, 1 minus 1 upon e. The first option is correct. Other will be cancelled out. So a very simple problem, Cauchy problem, but no need to solve fully. We just see what we want. We want only here ux0 is equal to sine x. So y is changing, so we have solved y u only. From here we get u01. Let's take another problem. Again, a similar type of problem, but different from previous. The general solution of the surfaces which are perpendicular to the family of surfaces z square is equal to kxy. Here we are to find the general solution. If the same would asked in the previous question, find the general solution of this equation. So what we can do here, from first two equation we find one, and from another two we find another. Say from first we get phi xy is equal to c1, suppose, and from this we get some another, say g y u as function of y and u is equal to c2. Then we can write from here the general solution as a function which containing these two phi and g is equal to 0. Or we can write phi is equal to f of g. This is also can be the solution. Or we can write g is equal to function of phi. So these two solutions can be write combinedly to get the final solution as one of the three types. So let's take this problem now. So here we are to find the solution, but the family which is perpendicular to this family. So firstly, we have to find a perpendicular family to this. So how we can find a family which is perpendicular to this? This should be known. So take z square is equal to kxy. Just separate with a constant, taking k to the right hand side and the rest to the left hand side. So call it as a function of x, y, z. So if we want to write a family which is perpendicular to this family, this is a whole family, just differ by a constant. So we can write a perpendicular family, the equation of family which is perpendicular to this family. How we can write? Just taking curly f by curly x into p plus curly f by curly y into q is equal to curly f upon curl z, where p, q are the standard notation for first derivative of the function with respect to x and with respect to y. Here p, you already know, curl u upon curl x, q is curl u upon curl y, the similar thing. So this is a family which is perpendicular to given family. So we want first curl f upon curl x, curl f upon curl y, and curl f upon curl z. So here we have f is equal to z square upon xy. So from here we can write curl f upon curl x. Just partial derivative with respect to x. Here x inverse, so getting minus sign, then x square y. Similarly, we can find curl f upon curl y minus z square x y square, and also curl f upon curl z as 2z upon xy. Just simple derivatives, partial derivatives. Substitute here, we get minus z square x square y into p plus curl f upon curl y is minus z square upon xy square into q is equal to curl f upon curl z, that is 2z upon xy. Now, this is the required family, perpendicular family, and we want the solution of this family. We can write the solution by just writing Lagrange equation first. So writing Lagrange equation, dx upon this coefficient minus z square upon x square y is equal to dy upon this one minus z square upon xy square and dz upon this one, dz upon 2z upon xy. So in this, now we can solve one by one because we want the complete solution. At least two solutions, which will be right here. And from this solution, we can get the idea which two should be solved. From the first x and y, here also x and y, here also x and y, here also x and y. Solving x and y first. So solving these two first. Dx upon minus z square upon xy, and here dy upon minus z square xy square. Here x square y. Okay. So here we can see minus z square is cancelled out by minus z square. 1 xy is cancelled from 1 xy. Here we remain with x and here we remain with y. Now x dx is equal to y dy. These are separated now. So taking integration both sides, we get the integration of x is x square upon 2 and integration of y is y square upon 2 plus c1. It will give us x square is equal to y square plus 2c1, which is equal to x square minus y square is equal to some constant, say c dash. So we have the first one is family as x square minus y square. Is x square minus y square is here? Yes. In first option, in second, in third. Clearly fourth is cancel out. Fourth cancel out. Now we have the three remaining option. Let's see which satisfies the second one. Here the second one is either xz, x square plus z square or 2x square plus z square. It means now we have to solve only x and z. In x and z, x and z. So taking the last and first, x and z. So this pair will give dx upon minus z square upon x square y is equal to dz upon 2z upon xy. You can see from here dz upon 2z by xy. So in this, we get just cancelling 1z from 1z, xy to xy, remain with x. So x dx minus z is equal to dz upon 2. Now separating the variable, 2x dx is equal to keeping z this side minus z dz. The variable are separated. Now we can take integration both sides. So integrating it, the integration of x is x square upon 2. 2 to 2 cancel out. So we remain with x square only. And here the integration is minus z square upon 2 plus some constant, say c2. Taking 2 as LCM, 2x square is equal to minus z square plus 2c2. We remained with 2x square plus z square is equal to 2c2, or we can write it as another constant, say c double dash. So we get the another family as 2x square plus z square. So we can see from option 2x square plus z square in the third option. So the option number third is correct. The remaining two are also incorrect. So the final answer is the third option. A very easy question based on Cauchy problem also. The only difference is here we have to find first the family which is perpendicular. So this is the important point here, how we can find a family which is perpendicular to the given family. Let's move to another problem. Also a similar type of problem. We can see the general solution of the equation x curl z upon curl x plus y curl z upon curl y is equal to 0. इसमें आपको in this equation we have given a problem which is also a Cauchy problem. X curl z upon curl x. Again a similar type. xp plus yq is equal to 0. And we have the 4 option which is dependent. Z is equal to phi this. So one solution will get this and another is this. Either this and this. Either this and this. Similarly, this or this. Let's see. First of all, we will write Lagrange equation. So Lagrange equation will give dx upon x, dy upon y, the coefficient of these two, and here 0. So when we get zeros, write directly z is equal to constant. Dz is equal to 0. Comparison. So give z is equal to some constant. So one family is only z. So z is all in the 4 options. So no option is cancelled till now. Now taking xy relation, as all the 4 have xy, dx upon x is equal to dy upon y. Very easy, already separated. So taking integration both sides, we get integration of x is log x, integration y is log y. As log is both sides, so taking constant is also a log c. Now we can combine these. Log a plus log b, log a into b, and here log x. So we get x is equal to y into c, and taking family to one side is equal to constant. So we get x upon y, or we can write also mod, as we are taking logarithm. Logarithm is always done on a positive function. So mod x upon mod y. The option number first gives you mod x upon mod y. This is correct. This is not correct. Is x minus 1 upon y. We have not the solution. This is also not. This is also not. So the correct option is only the option number first. So let's move to another type of problems now. Different from the previous. I can surely say in the coming CSR NET exam, one question from Cauchy problem surely come, and one question from these type of problem. Now we are taking. The given equation is parabolic, either hyperbolic or elliptic. So how can we check a given partial differential equation as parabolic, hyperbolic, or elliptic? The given equation will be like this: x square, like here the option number first is curly 2u upon, say, curly x square, right here as a, suppose, plus b curly 2u upon curl x curl y, plus c curl square u curl 2u upon curl y square, plus some another first order derivatives. It can contain function of first order derivatives, or x, y, z is equal to 0. We only want this portion where the second derivatives are. We can write it as short form AR plus B S, and this as T. Or in many books, you can see the standard notation as RR SS TT plus this. Main focus is on the coefficients of the double derivatives, these 3 coefficients. We find, to tell the nature of partial differential equation, we find a relation s square minus 4rt. The square of middle one, curl x, curl y, the coefficient of curl to u upon curl x, curl y, minus 4 time of the coefficient of curl to u upon curl x square and the coefficient of curl to u upon curl y square. And if this greater than 0, then the equation will be hyperbolic. Greater than 0, that means hyperbolic. Is equal to 0, that will give you parabolic. And the less than 0 will give you elliptic. So these three type of nature can be asked in upcoming exam. These are the very simple problems. You just have to find s square minus 4rt. So let's take this example. In this example, the question asks, which of the following partial differential equation is not parabolic? The equation are given as, the first equation is x square curl to u upon curl x curl y minus 2xy curl u upon curl y plus y square is equal to 0. In this we can see we have the second derivative as here only. And which is the coefficient of curl x curl y? That means s is equal to x square. R is absent, so 0. T is also absent, so 0. So from here we can tell s square minus 4rt is equal to s square is x square is x to power 4 minus 0. So we get x raised to power 4. Here we know that the square of any number is either positive or 0. So this is either equal to 0 or greater than 0. It means this equation is either hyperbolic or parabolic. It can be parabolic for x is equal to 0. Here it is saying for all xy. For all xy. If this question asks for x greater than 0, then this equation is hyperbolic, which is not parabolic. Then the option can be true. But here, strictly said, the xy belong to R. So if we take x is equal to 0, then this equation is parabolic. And they have asked about not parabolic. So the option number first is cancel out. Now moving to our second. From the second option, we have x square curl 2 upon curl x square minus 2xy curl 2u upon a curl x curl y plus y square curl 2u upon curl y square is equal to 0. From here we can see the second and the fourth are the similar. The second order terms are similar and we are only deal with this second order terms. No need to worry about first order terms, first derivatives terms. So if we check second, the fourth will automatically checked. In this fourth, we have s is equal to minus 2xy, r is equal to x square, the coefficient of x square, and t is equal to y square. S square minus 4rt. The square of minus 2xy is 4x square y square minus 4rt. So this will clearly give you 0. That means parabolic. This equation is confirmed parabolic. We will come to again the option number first. Firstly, the second is parabolic. Yes, it is parabolic. Fourth is also parabolic. Yes. Now the third equation says this is same x square. This is also same y square. The only difference is here. Here negative, here positive. So we are squaring this term. This will give you also the same behavior. It will also give you 0. So this is also a parabolic equation. These three are parabolic. Yes, yes, yes. But this equation either hyperbolic or parabolic. So in case of hyperbolic, this is not a parabolic equation. So this is the more correct answer. So the option number first will be ticked as the answer, which the question says not parabolic equation. So the option number first is the right answer, and second, third, fourth will be cancelled as all these three are parabolic surely. So let's take another this type of problem where we have to check parabolic, elliptic, or hyperbolic. So in this question, we have two partial differential equations. The first one is curl 2u upon curl x square plus 2 curl 2u upon curl x curl y plus 1 minus signum y. This is the important here. Many of you may not know this function. What is this function? Signum function of some variable y. It will give you value either 1 or 0 or minus 1. 1 for all positive y. When y is equal to 0, the answer will be 0, and y is less than 0 will give you answer minus 1. So this is the important part here. And in the second equation, we have y curl 2u upon curl x square plus x curl 2u upon curl y square is equal to 0. In this equation, in both the part, first see the options. What options want? Option wants the equation first is parabolic for y greater than 0, elliptic for y less than 0. There is restrictions on y. Also here restriction on y. And equation second, restriction on first and third quadrant, second and fourth quadrant. So let's deal one by one. First take equation number first. In equation number first, we can see S is equal to, S is the middle part, 2, the coefficient of curl x, curl y. R is equal to the coefficient of x square, that is 1, and T is equal to this, 1 minus signum y. So in this, S square minus 4RT will give you 4, S square is 4, minus 4R into T, 1 minus signum y. Further, solving this, 4 minus 4 plus 4, signum y. Here we can cancel 4 to 4. We only have 4 signum y. Now, relate this with signum function y. Here we can see the value can be either 1, 0 or minus 1. So when this value is 1, when y greater than 0, 1 into 4, that is 4. This will be 0, then 4 into 0 is also 0 when y is equal to 0. And when y less than 0, this answer is minus 4. So from here we can see, in the first situation, the answer is positive. That will give you hyperbolic equation. When answer is 0, that will give you parabolic equation. When answer is negative, that will give you elliptic equation. So for y greater than 0, the equation is hyperbolic, and for y less than 0, the equation is elliptic. So from here we can see greater than 0 is hyperbolic and less than 0 is elliptic. So option second is correct and first is cancel out. The first one says y greater than 0 will give parabolic, which is not true. Now, moving toward the equation second. What equation second says? Y curl 2u upon curl x square. That means the value of R. The value of S is 0 here, as the coefficient of curl 2u upon curl x curl y is absent, and the T will give you x, the coefficient of y square. So from here, S square minus 4RT give you 0 minus 4xy. And we are to discuss here first and third quadrant, second and fourth quadrant. So when we are taking the quadrants, this is first quadrant, second, third, fourth. We know that here x positive, here x negative, here y positive, here x y negative. That means this will give you also x positive and y both positive. First quadrant, and third quadrant will give both negative. So when both positive and both negative, negative, negative also positive, positive, positive also positive. So in first and third quadrant, here S square minus 4RT will give you this positive and multiply by negative. The answer will be negative. That is less than 0. So in first and third quadrant, the equation is elliptic. So first and third quadrant equation is elliptic, and the converse will happen in second and fourth quadrant, because in second and fourth quadrant, one is positive, second is negative, first is negative, then second is positive. So negative, positive will negative, and negative into negative, that is positive. So answer will be positive in second and fourth quadrant. That means hyperbolic. So second and fourth quadrant will give you hyperbolic. That means option number third is correct, and fourth will be cancelled out. So this is the problem in which we have conditions on x and y, or either on quadrant, but the same technique is used, which is s square minus 4rt. So whenever the nature of the equation is asked, the second order equation, either parabolic, hyperbolic, or elliptic, we can do and solve the question in similar manner, and the chances is 95% here for this exam. This type of question can be seen. So let's take one more problem of this type of question to make it more clear.
One time repeat this problem.
Yeah, we are repeating again.
One time repeat this.
Okay, sure. So here we have two equations. One will give you the equation of type, one second. Yeah. The equation of type curl 2u upon curl x square plus 2 curl 2u upon curl x curl y plus 1 minus signum y curl 2u upon curl y square is equal to 0. In the first two options, we asked about equation number first, and the last two equation, the equation number second will be D. So taking first equation, we have the coefficient as 1 of curl 2 upon curl x square. That means the R is 1, S is 2, and 1 minus signum y, that is t. So finding s square minus 4rt, 2 square 4 minus 4 into r into t. 1 into 1 minus signum y, that is 1 minus signum y. Solving further, 4 minus 4 plus 4 signum y. Cancelling 4 to 4, we get 4 signum y. Now we know about signum function here. When y greater than 0, the value is 1. When y is equal to 0, the value is 0. And y less than 0, the value is minus 1. So taking these values here, when y greater than 0, this is 1, but 1 into 4 is 4. So answer is 4 when y greater than 0. When y is equal to 0, answer will be 0. When y less than 0, minus 1 into 4, that is minus 4. So from here we can see when it is positive, that means hyperbolic. 0, that means parabolic, and when it is negative, that means elliptic. So for all y greater than 0, it is hyperbolic. For all y less than 0, this is elliptic. So the given equation says the second option also the similar one, y greater than 0 is hyperbolic and y less than 0 is elliptic, which is the second one, correct? And that will cancel the option number first. As for y greater than 0, it is not parabolic. Is it clear?
Yes, ma'am. Proceed.
Okay.
Proceed.
Yeah, similar manner you can do the second one option. In the second one option, this is R, S is absent here, so S is 0 and T is X. So solve in the similar manner, S square minus 4RT, we get 0 minus 4XY. Now depending on first and third quadrant, second and fourth quadrant, in both the option, they ask about first and third, second and fourth quadrant. So we know in first and third quadrant, either x and y both positive, x and y both negative. So when we take both positive, both negative, this will become positive, and positive into negative is also negative. So answer will be negative, and negative will give you assurance of elliptic. So in first and third quadrant, the equation is elliptic, and in second and fourth quadrant, the equation will be hyperbolic, opposite of that. So for making it more clear, this concept, we will take one more question on this type of problem. One more question. The question says, e raised to power x, the second order partial differential equation here, e raised to power x curl 2u upon curl x square plus x square plus y square minus 1 curl 2u upon curl y square is equal to 0 is the only single equation, and the four option is as either elliptic inside the unit circle, hyperbolic outside the unit circle, elliptic outside the unit circle, or parabolic for all xy. Let's see, more focus is on unit circle. Unit circle is the circle with center 0, 0 and radius 1. That means x square plus y square is equal to 1. So this question is asking the interior or outside the unit circle. That means x square plus y square either less than 1 or x square plus y square either greater than 1. What is the behavior in these two reasons mainly? So let's take the coefficient. This one as r e raised to power x. Here s is 0 and t is equal to s square plus y square minus 1. So finding s square minus 4rt is as 0 square minus 4 into r into t, s square plus y square minus 1, which is equal to minus 4 e raised to power s x square plus y square minus 1. Now we know that e raised to power s is always positive. We know the graph of this like this. For x tending to infinity, the e raised to power is also tending to infinity. When x is 0, y is 1, e raised to power 0 is 1. And for negative side, it will approach towards 0. So for all value, e raised to power x is always positive. For all y, always positive. So this is always positive. Now the situation is on this. When we are taking the interior of unit circle, x square plus y square less than 1. In this situation, x square plus y square minus 1 less than 0. So in the interior of unit circle, this will become negative into positive into this is also negative. So negative, positive, negative is also positive. Negative, negative, positive. That means greater than 0. So in this situation, the given equation becomes hyperbolic. When we are taking interior inside the unit circle. So inside the unit circle, the equation is hyperbolic. Here we have inside the unit circle elliptic. This will cancel out. Outside the unit circle, hyperbolic or not, that we will check. Also outside here, we will check. So let's take the outside of unit circle. Outside of unit circle is x square plus y square greater than 1. This will give you x square plus y square minus 1 greater than 0. So now positive 1. So this is positive. This is also positive. This is negative. Negative, positive, positive. That means negative, less than 0. So outside the unit circle, it must be elliptic. So elliptic outside the unit circle is correct option. This will also cancel out hyperbolic. And the fourth option is clearly cancelled. As for all xy, it is not parabolic. For some xy interior, it is elliptic. For some xy, it is hyperbolic. So this will option is also cancelled out. The only right option is the third one. The third option is right. So from here, we can easily see these kind of problem are very easy. Just focused on RST and find s square minus 4RT. And based on that, if it is greater than 0, then it is hyperbolic. If it is equal to 0, then it is parabolic. And if it is less than 0, then elliptic. The only way to find behavior of these equations. Now let's take another problem, a different type of problem based on partial differential equation. Which of the following expression for u is equal to uxt are the solution of ut, that means curl u upon curl t, minus, given equation is curl u upon curl t, minus e raised to power minus t curl u upon curl x, plus u is equal to 0. And with the condition says ux0 is equal to x. You are to find solution. Either the solution is first, either the solution is second, either the solution is third or fourth. See, we are not going to apply Lagrange equation here. You can do that also. You can find the solution by using your usual process, just writing Lagrange equation, then combining them as solution, then put the given condition, and then we will get the final solution. That can be the lengthy process here because they are asking about the journal solution. In the previous question, they are asking about the particular solution, which can be found easily than this. So in this question, we have one more. We can do one more thing. We can just try to take the options one by one, and we will check which one satisfy the given equation as well as the condition. Whenever you get stuck in any question of differential equation and you are to find solution, just take the option and check does it satisfying or not. That's it. You don't need to remember many formulas and many techniques to solve differential equation. Just take the solutions one by one and see which one is satisfying the given equation. So I'm going to solve this question in this manner. You can solve also like we have solved in the earlier three questions by taking the Lagrange equation, then solving one by one, first two, then second two, then combine them and put this initial solution. You can do in that way also. But now we are doing taking the option one by one. The first option says u is equal to e raised to power t x plus e raised to power t minus 1. So we can write it as e raised to power t into x plus e raised to power 2t minus e raised to power t. What we want, firstly, we will check does this satisfying the initial condition, the conditions which is given. Putting x is equal to x, t is equal to 0 because the solution is u x t. So the first value is for x and second is for t. Put x is equal to x, t is equal to 0. Did we are getting u is equal to x? Here we can see when t is equal to 0, this remain x, this remain 1, this is also 1. 1 to 1 cancel, we get only x. Yes, this is satisfying this initial condition, this condition. So now we will check only this. So what this equation required? This required curl u upon curl t, also required curl u upon curl x, and u we have given. So first find curl u upon curl t. That will give you e raised to power t x. The derivative of e raised to power t is e raised to power t. The derivative of e raised to power 2t is 2 into e raised to power t minus e raised to power t. And also find curl u upon curl x. That will give you with respect to x partial derivative e raised to power t only. So substituting these two values in equation number 1, does it satisfying or not? Curl u upon curl t, that means e raised to power into x, e raised to power 2t minus e raised to power t. Further, minus e raised to power minus t, multiplying it by curl u upon curl x, that is e raised to power t plus u. U is given as this, e raised to power t into x plus e raised to power 2t minus e raised to power t. Thus, it will become 0 or not. Let's check. The options which are cancelling with each other, we can here see that minus e raised to power tx here and also here 2 times of e raised to power tx, and also this will become 1. Clearly we can see it will not become 0 as all are doubled here. We already seen here. So this will not be 0. So the option number first will be cancelled because this is not satisfying the given equation. This equation is not satisfying here. Similar way, we can check the option number second, third, and fourth. Here we can see third and fourth are the simpler one type of equation. So we can first check third and fourth, then we can check second also. So let's try third and fourth. If both are cancelled, then automatically the second will be true. This is the lengthy one. Then these two To check these two is easy than the second, because second one is more complicating equation than the third and fourth. So let's try third first, then we try fourth. So third option is x minus e raised to power t plus 1 u. Firstly, check the initial condition is satisfied or not. ux0 is equal to x. Put this, x will be x, e raised to power 0, 1 plus 1. Yeah, this is satisfying. Now finding curl u upon curl t, that is minus e raised to power t. Curl u upon curl x, that is 1. Okay. Now substituting this in given equation is ut minus e raised to power minus t ux plus u. Ut is minus e raised to power t minus ux is 1. So minus e raised to power minus t plus u. U is x minus et plus 1. So this is also not become 0. So this is also not the required solution. Third option is also cancelled out. Fourth option, also we can check ux0 x or not. Yeah, this initial condition is satisfying. Now check the derivatives. Curl u upon curl t, curl u upon curl x. The option is, fourth one is x e raised to power t. So ut is x e raised to power t, ux is e raised to power t. Substituting this in solution, ut minus plus u. Ut is x e raised to power t minus ux is e raised to power t plus u, x et. So this also didn't become 0. So this option is also cancelled out. The only remaining option is second. So second one is the correct answer. You can also check the second option by this manner. When we put initial condition, this is satisfying. When we put this in the given equation, this also will satisfy. So the option number second is only correct. And you are thinking checking one by one option is taking much time. No, it will not take time. When you do practice, it will done more fast than finding the solution by the usual long method. Okay, so let's try another problem. So here, this problem is based on partial differential equation and to find the solution of second order partial differential equation. Let uxy solve the partial differential equation this. The equation given as x square curly 2 upon curly x curly y plus 3 y square u is equal to 0 with the condition ux0 is equal to e raised to power 1 by x. Which of the following statements are true? You have to tell in which of the following is true. So here we can see first option is partial differential equation is not linear or linear. So how we can check the given equation as linear or non-linear? In the similar manner, like in ordinary differential equation. Just see all the derivatives have the power 1. First option, power should be 1. Second point, you have to check the derivatives are not multiplied by the dependent variable. And the dependent variable is also not in higher power. It should also in power 1. So here we can see the derivative is here only, which has power 1. Dependent variable is u. Independent variable are x and y. So u is also power 1 here. So the power is 1 in the given equation. Also the multiplying is independent variable. Here also independent variable. X and y both are independent here. The derivative and u are not multiplied with the u again or the function of u. So this condition is also satisfying. So the given equation is linear equation. So the first option is cancel out as the option says not linear, but the given equation is linear. Now taking the option number second, third, and fourth. The second option says the value of u11. So for finding value of u11, we have to find the solution. As the initial we have given at the value 0. So we cannot find at u1 by using this right now. So hold the option number second and third. Let's see the option number fourth first. The option number fourth says the method of separation of variables can be utilized to compute the solution. Now the question itself giving you hint how to solve this problem. The question is saying using separation of variable. So use method of separation of variable. Can we find the solution by using this method? So let's take this method. Let's have a look. So in separation of variable method, what we do, we write the solution by separating the term of x and y, x the function of x, y the function of y. Let us assume the solution as the x part one side, y side one part, multiplying together. So this is the method of separation of variable when we applying the solution in this manner by separating both. So just what we will do here, we will substitute this solution in given equation, and using the condition, we will find the solution first. If solution find, then the option number fourth automatically correct because we are using this method. And if we have compute the solution, yes, then the option number fourth will be correct. If we didn't find the solution, then the option number fourth will be incorrect. So let's find this first. Curl 2u upon curl x curl y. That means firstly the derivative with respect to y. So I'm putting the derivative symbol as y dash. That means the derivative with respect to y on y. And then the equation should be derived with respect to x. So on x, that means the derivative with respect to x. Substituting this in first, we get the given equation. In the first given equation, x square into x dash y dash. X dash is function of x with respect to x derivative, and y dash is function of y with respect to y derivative. So for the 3y square u, 3y square u is what? X into y is equal to 0. So by this, we have here x square x dash y dash is equal to, taking this to the right hand side, we get negative of 3y square xy. Now separating the variable, taking x terms this side and y terms this side. Now this whole depend on x only, this whole depend on y only. So making these two equal, we must say this will be equal to some constant, say k. To making these two different variables equal, then both must be equal to some constant. This is the only option here. Now taking one by one, take first to the k and then second to with the k. X square x dash upon x is equal to k, and another equation is y dash is equal to k. Solving one by one, when we solve this, x square dash upon x is equal to kx square. So this will give you the integrating both sides with respect to x dx. This will give you logarithm of x. As we know, when derivative is above and the below is that function, then the integration of this function is logarithm of x is equal to kx cube upon 3. The integration of k, one second, k upon x square is here because we have taken x square to the below. So writing integration again, here the integration will become k x raised to power minus 2 will give you minus k upon x, integration of this, plus log c1, say, because logarithm is here, so we have taken constant is also as log function. So separate this, x is equal to, we can write this equation as log and e raised to power. So we get log of x is equal to log e raised to power minus k upon x into C1. Log a plus log b is log a into b. So cancelling log both sides, we get e raised to power minus kx into C1. So this is the solution for x only. Now finding solution for y, taking y dash to the this side and y to the below, minus 3y square upon k. Now integrating both sides, we get here log y is equal to the integration of this minus y cube upon k plus c2. Another constant c2 or log c2. In the similar manner, y is equal to c2 into e raised to power minus y cube upon k. Similar manner as we have find for x. So now we have the solution for x also, for y also. We know that uxy is equal to x of x into y of y. So multiplying both, we get c1 into c2 as another constant, say c into e raised to power minus k upon x into e raised to power minus y cube upon k. This is the required solution. Yes, we can find the solution by using separating variable. Now, for finding the value of constants, we first have to use this initial condition. The condition is given as ux0 is equal to e raised to power 1 upon x. So substituting this equation here, then we get the value of constants and then we can solve further. Substituting y is equal to 0. So u will become e raised to power 1 by x. Y is equal to 0. E raised to power 0. That is 1. So comparing both, we get, after comparison, c is equal to 1, k is equal to minus 1. From here, k is equal to minus 1. And from here, c is equal to 1. So substituting back, we get the final solution as uxy is equal to c as 1, e raised to power k minus 1, that will give you e raised to power 1 by x. K as minus 1 will give you only y cube. So the final answer is e raised to power 1 upon x into e raised to power y cube. And we are to find u11. The options want the value of u11. So substituting x is equal to 1, y is equal to 1, e raised to power 1 into e raised to power 1, that is e raised to power 2. So the final answer is e square. The option number second is correct and third is wrong. So the final answer is second and fourth, and this question is 4.75 marks and an easy question. Just you have to use the separation of variable method, and which question itself saying use this method. You can get the solution. So the partial differential equation, ordinary differential equation are very easy in the NET examination. The options itself says the answer. Just you have to read each line very carefully. You itself get the answer. Let's take another problem. The problem is based on Wronskian. We have already covered a lecture on Wronskian. The basic property of Wronskians, you should everyone know about the properties of Wronskian. A very easy property. The Wronskian is found on the two functions. Firstly, basically f1, f2, which is given as the function f1, f2, f1 dash, f2 dash, the derivative of this, and then the determinant. Basically, the problem up to two functions seen in the previous years. It can be on more functions, then more derivative will be found and the determinant change accordingly. Here for 2 cross 2, if 3 function, then 3 cross 3, and goes on. And also, it has some properties. If the two functions are solution of given differential equation, then either the Wronskian will be identically 0 and it will become the both solution as linearly dependent. If this is not 0 for any x naught, for some x naught say, then it will become Li, and the Wronskian will keep the same sign if either whole positive, either whole negative, or identically 0. It will depend what type of problem is. So based on these simple properties, you can find the questions within 2 seconds even. So read carefully. The question says Consider the second order ordinary differential equation. What the equation is? X double derivative plus pt x derivative plus qt into x is equal to 0. Here we can see, let x1, x2 be two solutions of this ordinary differential equation. The solution is x1 and x2 of this problem. We know that up to second order degree, the two solution will be found, and the two solution are the solutions for which they are asking which of the following statements are true for Wronskian of x1 and x2. If you are finding the Wronskian of these solutions, x1 and x2, then what is true from these four options? The first option says Wronskian is identically 0 in AB implies that x1, x2 are independent. Totally wrong. We have in the point first, when this is identically 0, then the equation become linearly dependent. So the first option is clearly incorrect. The second option says Wronskian can change sign in AB. In third point, I have mentioned either upward or negative throughout or identically 0. So this is also wrong. Wronskian cannot change in sign AB. The third option says if Wronskian 0 for some t not belong to AB implies that Wronskian identically 0. Yeah, we have seen if somewhere it is not 0, suppose if somewhere it is not 0, then it will become Li, and for Li it cannot be identically 0. So if it is once 0, then it will remain 0 only. It will keep the same track. So if it is 0 for some, then it will identically 0. The fourth option says if Wronskian is 1 for some t naught, then imply that Wronskian is identically 1. Now think this. This is saying if Wronskian value is 1, now it can be 2, 3, 10, 20, we have no problem because the Wronskian will be greater than 0. But it is not compulsory. It will remain totally same. This is not compulsory here. Okay. So the option fourth is also incorrect. It's saying greater than 0. That means not identically equal to 1, but the Wronskian will keep greater equal to 0, greater than 0 always. So the option number only third is correct, and even this question in 3 marks, single answer type. So once you have seen this question, the question is totally free to you.
Can you repeat third
You can get
option
the full.
once?
Yeah. Any problem?
Can you repeat third option once?
Which one option?
Third.
Third. Okay. The third option is saying if Wronskian at some point is 0, Wronskian at t naught is equal to 0. For some t naught belong to AB. It means at single point it is 0, surely. Does it implies that Wronskian will be identically 0 in AB? See, if we take counter, let us assume the Wronskian is not identically 0. If Wronskian is not identically 0, that means either it is upward or downward, either it is positive or negative. In both the situation, it will give you Li. And if we are saying Li, that means it cannot be 0. Yeah, it means either totally positive or totally negative. But the option says it is 0 at some point. So we get the contradiction to our assumption. So our assumption is wrong. That means Wronskian is identically 0. So if Wronskian once 0, then it will become identically 0 throughout. Clear?
Ma'am,
Yes.
please explain the fourth option also once.
Okay. Okay. Fourth option is saying if Wronskian is 1, then for some, even for some t naught belong to AB, then you can say Wronskian is all over 1 in AB, See, let's take an example to cancel out this option. Suppose you are to find Wronskian of 1 and x. Let's take an example. In the interval, suppose 1 by 2 to 2. The interval is a to b, that is 1 by 2 to 2. And you are to find Wronskian of 1 and x. So writing 1 here, x here, the derivative of this, just change little bit, x and x square. X square. So in this, the derivative of x is 1 and x square is 2x. It will give you 2x square minus x square, that is x square. Now in this interval, we have seen at x is equal to 1, the value of Wronskian x square is equal to 1. When we put x is equal to 1, the value is 1. Now, can you say the rest of the point also the value is 1? When you are taking the point, suppose 2, then the Wronskian of x square becomes 2 square is 4. The Wronskian is not equal to 1. So here, clearly we can see the Wronskian is 1 for some point and some another point it is different. But it is following the rule. The rule says once the Wronskian is non-zero, and it will keep the same sign. Sign means once it is greater than 0, then it will definitely greater than 0 for become Li. In this interval, we can see the Wronskian is clearly greater than 0 for all 1 by 2 to 2. Clear?
Ma'am, if
Yes, ma'am.
Wronskian is not equal to 0 for all x naught means it is linear independent. That is true. For all or for there exists x naught.
Yeah, for all non-zero if it is the solution of given differential equation. The property of Wronskian says if it is once non-zero, then it will throughout non-zero.
Wronskian is not equal to 0 for all x naught means then it implies linear independent. That's my question.
Yeah, linearly independent it will be said. Even if it is for some x naught, then you can say it is linearly independent for even a single also.
Okay.
Let's move to next question, a different type of question. In this question, we have the concept of eigenfunction, eigenvalue, boundary value problem. So a totally different type of problem from the previous problem. Here we have, let u be a positive eigenfunction. Firstly, I will clear, if lambda is eigenvalue, then u will be eigenfunction when lambda is non-zero. Lambda is 0 also. Wait, u should be non-zero. We want non-trivial. If it is non-trivial, then we can say is it eigenfunction. So first thing is that many of you may be unclear about this, but the eigenfunction will exist only if u is non-zero. If we get a non-zero solution for the given eigenvalue, then it will become the eigenfunction. So non-zero it should be. Now, they have given one more condition. They have given positive eigenfunction. They have clearly said, yeah, if in any equation, in any question, they said we have an eigenfunction. That means it is non-zero. It is a non-zero solution of given equation. It cannot be a zero solution. Whenever they said it is eigenfunction, then clearly it is a non-trivial solution. It is not a trivial solution. Clear?
Yes, ma'am.
And they have said one extra condition, u be a positive eigenfunction. Positive eigenfunction, that means u strictly greater than 0. First condition is given that. With eigenvalue lambda, the eigenvalue is for the same as lambda for the boundary value problem. But the problem says u double derivative 2u derivative plus at is some function into u is equal to lambda u, where u dot 0 is equal to 0 is equal to u dot 1. The derivative of u at 0, derivative of u at 1, both are 0, where a is a function from 0, 1 to 1 infinity. See, this will also play a very important role. You will see further. Is a continuous function. It's a continuous function. Now, which of the following statements are possibly true? The first statement is lambda greater than 0. Second says lambda less than 0. Fourth says lambda is equal to 0. It means firstly we have to tell about the nature of lambda. If we have a positive eigenfunction, then what you can say about this lambda? First, we have to decide this. Then there is a relation in the third equation that we will see lastly. First, we will focus on lambda. So in this type of equation, for solving this, clearly we can see we use integration also. The third one option is. So firstly, check is the given equation is self-adjoint or not. Did you do the integration or not? Can you do or not? To do integration, first the equation should be self-adjoint. Self-adjoint means the derivative of this will be here, but the derivative 2 is 0, which is not here. So this is not a self-adjoint equation. To make it self-adjoint, we have to multiply it by integrating factor. This is a tough problem, I can say, but just understand what I'm saying. Integrating factor. Integrating factor will be find out by e raised to power integration this one when this coefficient is 1 to dx or dt, because here the independent variable we are taking dt. You can see here dt, dt, dt. So we get e raised to power 2t as integrating factor. So multiplying given equation by integrating factor, we get e raised to power 2t u double dot plus 2 e raised to power 2t u dot plus at e raised to power 2t u function of t is equal to lambda u function of t. Now we can clearly see, now this is self-adjoint. We can see the derivative of this is here, 2 e raised to power 2t. Now, we can write these two equations combinedly. How we can write? Derivative of e raised to power 2t into u dot. This is two functions. So by product rule, the first will remain as it is, the derivative of second plus the derivative of first and second will remain as it is. So we can write and replace this by this. Further, e raised to power 2t ut is equal to lambda ut. Now we have also the initial conditions. U derivative 0 is equal to 0, u derivative 1 is equal to 0. Now we can integrate this whole. So integrating here with 0 and 1 as boundary value problem, and we have the limit of boundary value problem 0 and 1 here. So integrating 0, 1, here also 0, 1 dt, and here also 0, 1 dt. So we get from derivative to integration cancel out e raised to power 2t u dot t 0 to 1 plus 0 to 1 at e raised to power 2t ut dt is equal to 0 to 1 lambda ut dt. Clearly, when we put 1, then u dot 1 is also 0 given, u dot 0 is also given 0. So this will become 0 when we put the limits. Here we have only left 0 to 1 at e raised to power 2t ut dt is equal to 0 to 1 lambda ut dt. Now see, we are to comment on lambda. So stop here. In the question, we have u as a positive eigenfunction. Also, a is the function whose range or codomain is in between 1 to infinity. That means also positive. A function is also positive because the codomain is positive. That means the answer or the range set is between these two limits, 1 to infinity. That means A is also positive. So A positive, U positive. Now coming further, this one positive, e raised to power 2t is also positive, ut is positive. Though the integration from 0 to 1 is also positive. The whole left hand side is positive. Here, u is also positive given. Integration from 0 to 1. To make it positive, lambda should be positive. For equating left and right side, both sides should be positive. So lambda should be positive. So we have concluded about lambda that lambda should be greater than 0. It cannot be less than 0. It cannot be equal to 0. Any doubt till now? We have just make the given equation self-adjoint, then did the integration only. Now, coming towards the option number 3rd. But option number 3rd is, I'm writing here. The option number 3rd is integration from 0 to 1 u dot square dt is equal to 2 0 to 1 u dot dt plus 0 to 1 at minus lambda u square dt. See, we have reached at this equation, which is not comparable to this equation. As this equation contains u dot square, u dot. So we have to start from the first now. Because this is not the equation which we can use to solve further our third option. For third option, we have to visit the given equation. So what is the given equation? We have to check this one. So first write the given equation. Given equation is u double dot plus u dot plus atu is equal to lambda u. Clearly we can see here at minus lambda u square. At minus lambda can be made, but u should be changed by u square. That means we have to multiply whole equation by u first. Then we can do the integration. Maybe we get the same situation. So by option, we can get the idea what we can do here. We only multiplying the whole equation by u, then do the integration. So multiplying whole equation by u double dot into u dot u plus at u square minus lambda is also, I'm writing u square is equal to 0. Now integrating throughout 0 to 1 dt, 0 to 1 dt, 0 to 1 dt. So this is the same one which we want. This is also the same one which we want. Now only this remains. We want to make this as this with negative sign even. So solving this, the only way to solve further, here we can see we are to cancel the double derivative and make it as single derivative. How we can do? We can integrate this, as this is extra differentiation. It is 2-time derivative and we want only 1-time derivative. So integrate this one. How we can integrate? Integrating by parts, taking it as first function and it as second function. First function as it is, the integration of second function, that means u dot, limit 0 to 1 minus integration, first function, derivative, second function, integration, dt. And the further will remain same, u dot u dt plus 0 to 1 at minus lambda u square dt is equal to 0. Now we can see from here, when we substitute the limits, again u dot 1 0, u dot 0 0, so this becomes 0. And taking this to the right hand side, we get 0 to 1 u dot square dt is equal to 0 to 1 2 u dot dt plus 0 to 1 at minus lambda u square dt, which is the required relation. So from given equation, we reached to the option number 3rd, and the option number 3rd will be correct as it can be found from the given equation. So this is true. Option number 1st and 3rd both are correct. So moving towards next question. The question number 12th. So this is also a different problem. Let y naught greater than 0, z naught greater than 0, alpha greater than 1. We have 3 different variables, y naught, z naught, alpha. Consider the 2 differential equation. Dy upon dt is equal to y raised to power alpha for t greater than 0. You can see here, this is the first order differential equations, a very simple equations which you studied, I think, in BSC's. A very simple equation with initial condition y0 is equal to y0. Initial value problem is given. One more equation, dz upon dt is equal to minus z alpha for t greater than 0, and z naught is equal to z naught. They have also given, we say that the solution to a differential equation exists globally if it exists for all t greater than 0. You can say the solution is exist globally if exists for all t greater than 0. That means if you substituting any of the t greater than 0 and you did not approaching to the limit 0, that means solution approaching to the limit infinity, that means solution exists. Finite, the solution will tell you about the exist globally. So the options are also saying about this. The equation number star and double star have global solutions. None of the equation have global solution. The star exists global solution, but for t less than 0, limit tending to infinity. For some t less than infinity, the limit tending to infinity. So we are to just find the solution is existing for all t greater than 0 or not. If it is existing for all t greater than 0, then we can say exist globally, otherwise not. So we can see the first
Ma'am,
equation.
can you repeat the definition of global solutions again?
Yeah, they are already given the definition in the question itself. They are saying you can see the solution with exist globally if you find the solution of this equation and that solution give you the finite value, exist finite value for all t greater than 0. So when you find the solution and finally you check for all t greater than 0, the solution is giving you the finite answer or not. If we giving you the finite answer, that means the solution exists and the solution will exist globally. Clear?
Clear, ma'am. Ma'am, but there is also local solution. Local solution is also.
Local are different. We are saying global solutions only here. Okay. In this question, we are telling about the global solutions only.
Is the definition same for every question? Like whenever
No.
the solution exists for all positive values, then it is a global solution.
No, they have given their own definition and then
Okay,
they are asking.
they have specified.
Yeah.
Okay, thank you.
Let's take first solve this equation, then we will further conclude it about the global solution. See, if we solve this equation by taking alpha greater than 1 as a journal, you can solve it as a journal also. But if we can take here to make us this our question simple, we can take alpha as 2, that is satisfying the given question. Question says alpha greater than 1. So we can take alpha as 2. Similarly, we can take y naught as 1, as simple as possible, greater than 0. And also take z naught is equal to 1, as here it is saying z naught greater than 0. So we can take as simple as possible. So now the question becomes dy upon dt is equal to y square. If they are asking about alpha greater than 1, that means the whole situation is same. So you can take any alpha greater than 1. It will give you same behavior as the behavior for alpha greater than 1. Because there is no confusion in the option. Either option will be, say it is global solution for all alpha, either none of them is global. So they are not have written the option like this. For some alpha, it is have the global solution. For some alpha, it don't have global solution. If they write in option like this for some, then we have to solve for journal problem. But now they are asking for any alpha greater than 1, so we can take any particular case to tell and conclude the solution. So this is the trick, short trick. But use the short trick at the right time, not in every question. So just by options, you can get the idea when to use these type of tricks. Separating the variable, taking y square this side and dt this side. Now integrating both sides, we get minus 1 upon y, integration of 1 upon y square, and here t plus c1. And also initial condition we have y0 is equal to 1. Y0 is equal to y0, and we have taken y0 as 1. Substituting this, y0 is equal to 1. That means y1 when t is equal to 0. So c1 value is minus 1. Here we get minus 1 upon y is equal to t minus 1, which gives you y is equal to minus 1 upon t minus 1, or you can write 1 upon 1 minus t. Here you can see when the denominator becomes 0, y will tend to infinity. When 1 minus t is equal to 0 will give you y tending to infinity. That means the solution not exist when you are taking t is equal to 1. It means there exists a t greater than 0. Hamara jo we have, the focus is only on t greater than 0. So when we are taking t is equal to 1, in this situation, the solution is tending to infinity. So the problem number star have not the solution globally exist. So the option number first will be cancel out, both have global solution. As one have not the global solution, that we are sure now. Okay. And also there exists a global solution for star. This option is also cancelled out. Third is also cancelled out. Now the remaining option is second and fourth. For saying this, let us solve double star equation. The double star equation says curl z upon curl t is equal to minus z raised to power alpha. Alpha, that means 2, and z at the value 0 is equal to z0, and we have taken z0 as 1. Again separating the variable, integrating both sides, minus 1 upon z is equal to minus t plus c2. For getting the value of c2, substitute the initial condition. Z is equal to 1 is equal to c2. So we get the value of c2 as minus 1. Minus 1. So here we get z is equal to 1 upon minus t minus 1 with negative sign. And here we get 1 upon t plus 1. T plus 1. So this is z here. So from here we can see that z tending to infinity when this will become 0. When t plus 1 is equal to 0. T is equal to minus 1. So at t is equal to minus 1, the solution does not exist. But accept this point, the solution is existing everywhere. Accept this. So for t greater than 0, excluding this, for t greater than 0, solution exists everywhere. That means for this equation, the solution is globally exist. The solution will globally exist if it exists for t greater than 0. So none of have global solution. That is also wrong, because one has the global solution, but another has not. This has the global solution, but this will not have. Now, there exists a global solution for double star. That is correct, but they are saying there exists a t less than infinity such that t tending to t will give you infinity. Yes, there is existing a number less than infinity. This number -1, which is giving you the solution towards infinity. That is right. There exists a t less than infinity, which is giving you the infinity answer. So that means the option number 4th is the correct one, and the rest are wrong. So moving towards another question. We are having short of the time, so let's speed up. The following 2-point boundary value problem. So this is also a different problem. In this, they are saying y double dash plus lambda y is equal to 0. This is also an important type of problem. Maybe this type of question can be seen in this year, this upcoming exam. The following 2-point boundary value problem, y double dash plus lambda y is equal to 0 for x belong to 0 to pi, y0 is equal to 0, y pi is equal to 0. Has a trivial solution, y is equal to 0. They are saying it has a trivial solution. Yes, we can see y is equal to 0 is satisfying this also and this also. So we know that a trivial solution is there. That is true. But they are saying it also has a non-trivial solution. That means y not equal to 0 for which of the lambda? For which of the lambda out of this? For no value of lambda belong to R. For lambda is equal to 1. For lambda is equal to n square and greater than 1. For lambda less than equal to 0. So we have to discuss lambda. For which lambda we can have y not equal to 0. So we can differentiate from here. We can see they are saying about lambda is equal to 1, lambda less than equal to 0, lambda is equal to some positive type n square and greater than 0. So we can divide our lambda into 3 cases. Either lambda is equal to 0, as 4th option says, either lambda less than 0, either lambda greater than 0. Even if the solution not exist for lambda is equal to 0, and they are saying non-trivial solution for lambda less than equal to 0, this option automatically incorrect. We need not to check about lambda less than 0. If this happens, let's see first for lambda is equal to 0. If either of these two, either one of these two have trivial solution only, the option number 4th will be cancelled, because they are saying non-trivial solution for less than 0 and equal to 0. Let's see one by one. We will check for lambda is equal to 0 also. We will check for lambda greater than 0 also, and we will check for lambda less than 0 also. So take the case number first when lambda is equal to 0. So substituting lambda is equal to 0 here, y double dash is equal to 0. When we are taking this, so from here we can directly write the solution as the first order ax is equal to b, because the second derivative of this equation is 0. Or you can solve it manually as d square is equal to 0. We get root 0, 0. So from here ax plus b. Now taking the conditions boundary value problem, y0 is equal to 0, y pi is equal to 0. Substituting y0 is equal to 0 here, 0 is equal to b. So we get the solution only ax when b is equal to 0. Substituting second equation, y pi is equal to 0. So a pi. Now pi cannot be 0. So the only option is a should be 0. So substituting a is also 0, b is 0. We get yx is equal to 0. So in this situation, we get a trivial solution, not a non-trivial solution. So lambda is equal to 0 cannot be the case which give you non-trivial solution. Now checking for lambda less than 0. Lambda less than 0 means lambda is equal to minus some positive number. Negative number can be written as in this form, where k belongs to either integer or natural number. The same case is when you are substituting here any of the natural number, that means the same case negative. And the option is also asking about, you can also take any real number also. That will also give you a negative real number. So let's move towards this. When we substitute this lambda square, lambda is equal to minus k square, y double dash minus k square, y is equal to 0. So now we will get the solution by using auxiliary equation, give you k and minus k root, and you can write the solution as c1 e raised to power kx, c2 e raised to power minus kx. If someone didn't know about the solution, how we can find the solution, then please revisit my last 3 videos. There I have discussed about how to find the solution of these type of constant coefficient equations. Now here, substituting the initial condition y0 is equal to 0 and y pi is equal to 0. So substituting y0 is equal to 0 give you c1 plus c2. c1 is equal to minus c2. So substituting back, yx is equal to c1 e raised to power kx minus c1 e raised to power kx. Substituting c2 is equal to minus c1. So here we are left with this solution. Now substituting y pi is equal to 0. So y pi e raised to power k pi minus e raised to power minus k pi. Now this cannot be 0 because you can see from here, if this is equal to 0, then e k pi is equal to e raised to power minus k pi will give you e k pi divided by e k pi is equal to 1 will give you e 2k pi is equal to minus k pi below is equal to 1, and this will give you 2k pi is equal to 0. E raised to power 0 is 1. But this cannot be 0 because k, we have taken negative real any number which is not equal to 0. Sorry, k is not equal to 0 because if k is 0, then we reach the case lambda 0. Lambda 0. But we are discussing about lambda less than 0. So k cannot be 0. Pi is not 0, 2 is not 0. So this cannot be 0, this cannot be 1, this cannot be 0. So this cannot be 0. The only option is to take c1 is equal to 0. And we are taking c1 0, then c2 automatically 0. c1, c2 both 0 will give you again trivial solution. So we have no interest in trivial solution. They are asking about non-trivial solution. So the only option we have left with lambda greater than 0. If this is true, the fourth option is cancelled out. If this is true, then option second and third can be true, but first will be cancelled because first is saying for no lambda belong to R. Now check lambda greater than 0. Substituting lambda greater than 0 means lambda is equal to k square where k belong to any real number accepting 0. Leaving 0 because if k is 0 then lambda is equal to 0. So substituting this, y double dash plus k square y is equal to 0. So in this case, b square plus k square is equal to 0 will give you plus minus iota k, and the solution will be c1 cos kx plus c2 sin kx is equal to y of x. Now using the initial conditions, y0 is equal to 0, y pi is equal to 0 will give you 0 is equal to c1. First, this is 0, cos 0 is 1, sin 0 is 0. So c1 is equal to 0. So we have remained only c1 cos, c2 sin kx because c1 is 0. Now substituting y pi is equal to 0. So substituting pi, sin k pi. Now either this can be 0 or this can be 0. If C2 is 0, then again trivial solution. But we want any non-trivial solution. So here can we do this 0? If we are taking sin k pi is equal to 0, yes, sin 0 at n pi. We can say this if equal to sin 0, that means sin n pi where n belong to any integer. For all integer, sin n pi is 0. Sin pi, sin 2 pi, sin minus pi, sin minus 2 pi, for all integers, it is 0. So comparing sin k pi with sin n pi, k pi is equal to n pi. So we reached k is equal to n, where n belong to any integer given. And lambda become k square, that means n square. Now writing n belong to either integer or either natural number, that is same thing, because when n is 1, the answer of lambda is 1. When n is minus 1, again the answer of lambda is 1. So avoiding negative term, we can write only positive term also. That will also give you the same lambdas. 1, 2 square is 4, also minus 2 square is 4. 3 square is 9, also minus 3 square 9. So these are the required lambdas which give you the final non-trivial solution. And the solution will be equal to, solution is equal to C2 into sine, the value of k is nx. That is the solution. So from the options, lambda is equal to 1, yes, it is giving you the non-trivial solution. 1, 4, 9, 16, all are giving you the non-trivial solution. And also these is n greater than 1 means 2 square 4, 3 square 9. Yes, these are also giving you non-trivial solution. So the option number 2nd and 3rd, both are correct. First is wrong. So the question is itself a lengthy question, but if you try more problems on these questions, then this question is not lengthy. You can do it in the way you can just check for lambda is equal to 0 and then directly check for lambda greater than 0. In most of the cases, the solution will be non-trivial for these two. So let's coming towards the next problem. Yeah, this is also another type of problem. This problem is saying about Cauchy problem. Cauchy problem is curl 2u upon curl x curl y is equal to 0, where mod x less than 1 and y lying from 0 to 1. We have also initial condition u x square is equal to 0, curl u upon curl y x square is equal to gx, where mod x less than 1. See, in this problem, a very different thing is here. We can find the solution manually also by using our normal method, which we do firstly derivative with respect to x, then derivative with respect to y to reach to u. Then we will substitute these values. But the options is asking about the function g. The option is saying the necessary condition for a solution to exist is that g is odd function or g is even function. It means you have to decide from the options what to do with the question. The question is asking about the function g. G is either odd function or even function. And also, they are asking about solution. So we can verify the solution by substituting back. This is the way. So for third and fourth option, we will check with the back substitution. We just verifying is this satisfying these equation. Then either third or fourth, which will be correct, we can see directly. And for g, we can use this because g is coming here only. What we can do, here we have curl u upon curl y. So substituting this value here, we can write this equation as this is equal to 0. We can write this equation as curl upon curl x to the outer, then curl u upon curl y is equal to 0. And substituting this here, we get at x square curl upon curl x gx is equal to 0. We just substituting this by gx, replacing this by gx. So here they are saying a function of x only have the derivative with respect to x equal to 0. This means this implies function should be constant. A function itself of x and the derivative with respect to x is 0. That means the function is constant. And can you tell me a constant function is even or odd? Anyone?
Even.
How to check? Yeah, even only. See, even function is a function which give you gx is equal to g of minus x. But the odd function is the function which give you after putting negative, the negative sign will be goes outside. So here we can check if function is constant, that means some value c. So its value is not changing anywhere. It is constant. When we substitute x and by minus x, that value will remain the same, c. There is no change in the function. And here c, this is c, which is not equal to minus c. So the function is only the even function. The constant function is always the even function, not the odd function. So the option number first is cancel out and second is true. So this is the very easy way to check the function g. Just using where the g is and substituting this in given equation. Now, the only option number third and fourth will be correct, which satisfy the given equation. So one by one, we can use this relation also. This relation is saying ux x square is equal to 0. See, we have to replace y by x square only for this. So when we replace y by x square in this, it will give you x to x square integration, which is not equal to 0. Here saying 0. So fourth option is automatically cancelled by only this condition. Only this condition. This condition is not satisfying in the option number 4. But in the third, it become y, replacing y by x square, x to x integration. So same to same integration, answer will be 0. So third option is satisfying this equation. Also check is it is satisfying this equation or not, and also this equation. Let us check. The option number third is uxy is equal to 2 times of x root y z into gz dy. And we are to find the derivative with respect to y. Derivative with respect to y. How we can do derivative with respect to y here? Very simple. Here the function z. Limit is based on y and x. And we have to do derivative with respect to y. So here we can use Laplace rule for taking derivative under the integration. So what Laplace rule say? Just do derivative with respect to y interior, then put upper limit minus lower limit in z, in place of z. So when we do the derivative with respect to y, this will be 0 because this function is not containing y. So the first step is 0. Plus, when we are putting upper limit in this, so substituting upper limit, in case of z, root y, g of root y, and the derivative of root y is 1 upon 2 root y. This is the upper limit. And when we are putting lower limit x, so minus, here we can see derivative of x with respect to y is 0. Because the function is dependent and we are doing derivative with respect to y only. So this will keeps the term 0. So we have only reached by using Laplace rule, curl u upon curl y, xy is equal to 2 under root g under root y upon 2 under root y. That is cancelled out. We have only remained g under root y. Now the function is totally dependent on y. Again, if we do the derivative with respect to x, this will give you 0. So the initial condition, the given equation is satisfying. Now only this left substituting y by x square. So here we, when substituting y by x square, here also x square, it will become gx. This is also true. So the given equation third, the solution third is satisfying the all three equation. So the option number third is also correct. The option number second and third, both are correct for this question. Now moving towards another problem. In this problem, we have a partial. Yes, repeating. Yeah, any doubt? Okay. Moving further.
Fourth option only, ma'am. Again, explain, ma'am.
Which one option?
Option 4, ma'am.
Option 4. See, option 4 have the u as 2 under root y limit x square g gz dz. Here when we have substitute y by x square, the solution is not becoming 0. You can see from here 2 y by x square, that means x square under root x, and upper limit is x square, z, gz, dz. This is not equal to 0. Here the limit x to x square, there is some function g, some function z, some function dz. With respect to dz, you are doing derivative. It is not becoming 0, but in the situation third, the limit is x to x, so automatically it is becoming 0. So this option, cancelling the option number 4th. Clear?
Okay, ma'am.
You can also verify option number 4th for this condition also. This condition is also not satisfying. If you have confusion in this, if you are having any doubt, then you can check this one. This is also not satisfying. This will give you an extra negative sign. So there are many ways. You can check any one from here. Now, there is one more. Yeah.
Excuse me, Kajal. We are almost out of the time. You can go. You can do this problem too. With that, we can. Okay.
Okay. Okay, sir.
Yeah.
So we have last question. As sir said, here we have partial differential equation. Z is equal to x, curl z upon curl x, y, curl z upon curl y, plus curl z upon curl x, curl z upon curl y. We can write it as xp y q plus p into q. This is a equation of first order, but here multiplying to first order. So this is a type of non-linear type. So in this type of equation, a very special kind of equation is given here. This equation is known as Clairaut equation. Clairaut equation is of type this, xp by q plus function of pq. And its solution can be directly written as, x a, replacing p by a, y by, q by b, and a b. Just simply substituting p by a and q by b. So here we can see the solution will become z is equal to x a y b plus ab. So the option number first is correct, second is false. For third and fourth option, you can just back substituting here. As I have told you earlier in the previous similar way, you can do this question just substituting this. Z is equal to x by 4 minus y whole square, and similar way substituting this. One will satisfy, one will not satisfy. You can check this very easily. This is a problem which can be came in exam earlier, and at this time this is also a very important one case. Just a simple problem. We can solve this in this manner. So I think so. You can do rest of the problem. This is a problem. I am giving you only hint. You can try by yourself. Here we have given the function f of x modulus is less than equal to 4 modulus of x for all x belong to real number. We are here to find the largest possible value of x1 modulus, where x dash t is equal to function of f of x. And also given x0 is equal to 3. Only 4 options are here which giving you the exact value, either 3 e raised to power 4, 4 e raised to power 3, and so on. So in this, we can assume a function which is satisfying this. We can assume function and take the function fx is equal to 4x. As 4x is always less than equal to 4 modulus of x, no issue. The modulus of whole function is less than equal to modulus when we separate. It is equal to even. So this is satisfying this problem. So taking fx as 4x, you can easily get the solution. Dx by dt is equal to 4x. Now separating the variable, substituting initial condition, you can reach to the answer very easily. And the last problem is the critical points. On the critical points, judging the nature of critical point. For judging the nature of critical point, just take this as f, this as g, and find the Jacobian of f and g. You can find Jacobian, curl f by curl x, curl f by curl y, curl g by curl x, curl g by curl y. Curl f upon curl x is 2x minus 2, curl f upon curl y is 2y, curl g upon curl x, and curl g upon curl y is 3. So at which point they are asking? They are asking at 0, 0. So substituting 0, 0, and you can form a matrix here. -2, 0, -1, 3. Now what you are to do here, only to find eigenvalues of this matrix. And by the eigenvalue, you can tell the nature of these 4. So just take that table, the table from the lectures of ordinary differential. You can see easily from the book S.L. Rose book or Andy Singhania book. In this book, you have clearly mentioned on the nature of eigenvalue. Here we can see the eigenvalue is -2 or 3. If the eigenvalue are distinct,
Point.
yeah,